Normalization should be part of the database design process. However, it is difficult to separate the normalization process from the ER modeling process, so the two techniques should be used concurrently. Use an entity relation diagram, or ERD, to provide the big picture or macro view of an organization's data requirements and operations. This is created through an iterative process that involves identifying relevant entities, their attributes, and their relationships. Normalization procedure focuses on characteristics of specific entities and represents the micro view of entities within the ERD. So, what is normalization? Normalization is the branch of relational theory that provides design insights. It is the process of determining how much redundancy exists in a table. The goals of normalization are to be able to characterize the level of redundancy in a relational schema and provide mechanisms for transforming schemas in order to remove redundancy. Normalization theory draws heavily on the theory of functional dependencies. Normalization theory defines 6 normal forms, or NF. Each normal form involves a set of dependency properties that a schema must satisfy, and each normal form gives guarantees about the presence and/or absence of update anomalies. This means that higher normal forms have less redundancy, and as a result, fewer update problems. Normal forms. All the tables in any database can be in one of the normal forms we will discuss next. Ideally, we only want minimal redundancy for PK to FK. Everything else should be derived from other tables. There are 6 normal forms, but we will only look at the first 4, which are first normal form, or 1NF, second normal form, or 2NF, third normal form, or 3NF, Boyce Codd normal form, or BCNF. BCNF is rarely used. In the first normal form, only single values are permitted at the intersection of each row and column, hence there are no repeating groups. To normalize a relation that contains a repeating group, remove the repeating group and form 2 new relations. The PK of the new relation is a combination of the PK of the original relation, plus an attribute from the newly created relation for unique identification. Process for 1NF. We will use the student grade report table as follows from a school database as our example to explain the process for 1NF. Student grade report. Student number, student name, major, course number, course name, instructor number, instructor name, instructor location, grade. In the student grade report table, the repeating group is the course information. A student can take many courses. Remove the repeating group. In this case, it's the course information for each student. Identify the PK for your new table. The PK must uniquely identify the attribute value, student number, and course number. After removing all the attributes related to the course and student, you are left with the student course table, student course. The student table, student, is now in first normal form with the repeating group removed. Student, student number, student name, major. Student course, student number, course name, instructor number, instructor name, instructor location, grade. How to update 1NF anomalies. Student course, student number, course name, instructor name, instructor location, grade. To add a new course, we need a student. When course information needs to be updated, we may have inconsistencies. To delete a student, we might also delete critical information about a course. Second normal form, 2NF. For the second normal form, the relation must first be in 1NF. The relation is automatically in 2NF if and only if the PK comprises a single attribute. If the relation has a composite pk, then each non-key attribute must be fully dependent on the entire pk, and not on a subset of the pk. That is, there must be no partial dependency or augmentation. Process for 2NF. To move 2NF, a table must first be in 1NF. The student table is already in 2NF because it has a single column pk. When examining the student course table, we see that not all the attributes are fully dependent on the pk, specifically all course information. The only attribute that is fully dependent is grade. Identify the new table that contains the course information. Identify the pk for the new table: student, student number, student name, major, course grade, student number, course number, grade, course instructor, course number, course name, instructor number, instructor name, instructor location. How to update 2NF anomalies. When adding a new instructor, we need a course. Updating course information could lead to inconsistencies for instructor information. Deleting a course may also delete instructor information. Third normal form, 3NF. To be in third normal form, the relation must be in second normal form. Also, all transitive dependencies must be removed. A non-key attribute may not be functionally dependent on another non-key attribute. Process for 3NF. Eliminate all dependent attributes in transitive relationships from each of the tables that have a transitive relationship. Create new tables with removed dependency. Check new tables as well as tables modified to make sure that each table has a determinant and that no table contains inappropriate dependencies. See the 4 new tables as follows: student, student number, student name, major, course grade, student number, grade, course, course number, course name, instructor number, instructor, instructor number, instructor name, instructor location. Normalization and database design. During the normalization process of database design, make sure that proposed entities meet required normal form before table structures are created. Many real-world databases have been improperly designed or burdened with anomalies if improperly modified during the course of time. You may be asked to redesign and modify existing databases. This can be a large undertaking if the tables are not properly normalized.